When running underground wiring to a detached garage, it's essential to ensure proper grounding fault circuit interrupter, or GFCI, protection for safety. In your situation, you're extending an existing three-way switch circuit to the garage and adding a continuous hot for a receptacle. The question is whether you can use the existing neutral wire for the three-way switch as the neutral for the GFCI protected circuit without causing issues. The answer is yes, you can use the existing neutral feeding the three-way switch as the neutral from the load side of the GFCI without causing GFCI tripping problems. Here's how it works. The GFCI device is installed in the house, typically where the circuit originates. It protects the downstream wiring and equipment connected to its load side. The continuous hot wire and the neutral wire from the load side of the GFCI are run underground to the garage. This provides GFCI protection for the receptacle and any lights connected to the circuit in the garage. Here's a step-by-step explanation. Firstly, the incoming power from the main panel in the house connects to the line side of the GFCI receptacle. This includes both the hot and neutral wires. The line side is where the power enters the GFCI. Secondly, the existing three-way switch circuit includes a neutral wire. This neutral wire is connected to the neutral terminal on the load side of the GFCI. The load side is where the protected power exits the GFCI. Thirdly, the continuous hot wire for the garage receptacle is also connected to the hot terminal on the load side of the GFCI. This hot wire runs underground to the garage. Fourthly, in the garage, the continuous hot wire is connected to the receptacle, providing power to it. The neutral wire from the GFCI load side is connected to the neutral terminal of the receptacle in the garage. Fifthly, the switch legs for the three-way switch are connected to the other two terminals of the three-way switch in the garage. These switch legs control the light in the garage, allowing them to be switched from both the house and the garage. When a ground fault occurs, the GFCI detects an imbalance between the hot and neutral wires. If the current returning through the neutral wire is different from the current going out through the hot wire by a certain amount, typically 5 milliamps, the GFCI trips, cutting off power to the circuit. By connecting the neutral wire for the three-way switch to the load side of the GFCI, you ensure that any ground faults in the garage will be detected by the GFCI, tripping it and cutting power to both the receptacle and the lights. This setup ensures that the entire circuit, including the receptacle and lights in the garage, is GFCI protected. This configuration will not cause any nuisance tripping of the GFCI, provided the wiring is done correctly and there are no actual ground faults in the system. Here are some key considerations. Firstly, ensure that all wiring is done in accordance with local electrical codes and the National Electrical Code, or NEC. Secondly, use appropriately sized conductors for the circuit to handle the expected load. Consult NEC Table 310.15 for proper ampacity based on wire size and insulation type. Thirdly, use a properly rated underground feeder, or UF, cable for the underground run to protect the wires from moisture and physical damage. Fourthly, ensure the GFCI receptacle is rated for the environment in which it is installed. If it's outdoors or in a damp location, use a weather-resistant GFCI receptacle. Fifthly, properly ground the receptacle and any metal boxes in the garage to ensure safety. Connect the grounding conductor to the grounding terminal in the receptacle and the metal box. Sixthly, before working on any electrical circuit, always turn off the power at the breaker to avoid electrical shock. Use a non-contact voltage tester to verify that the circuit is de-energized. Seventhly, consider the use of a surge protector at the main panel to protect your electrical equipment from voltage spikes and surges. Surge protectors can help extend the life of your appliances and electronics. Eighthly, label the GFCI receptacle clearly to indicate that it protects the garage circuit. This can help prevent confusion in the future. Ninthly, inspect the wiring regularly for any signs of damage or wear. Replace any damaged wiring immediately to prevent electrical hazards. Tenthly, ensure that all connections are tight and secure to prevent loose connections, which can cause overheating and electrical fires. 11thly, if you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electrical work can be dangerous, and it's important to ensure that it is done safely and correctly. 12thly, check the voltage drop on the circuit to ensure that the voltage at the garage receptacle is within acceptable limits. Excessive voltage drop can cause appliances to malfunction. 13thly, use a separate grounding electrode system, or GES, for the detached garage if required by local codes. This may involve driving a ground rod into the earth and connecting it to the grounding system in the garage. 14thly, consider using arc fault circuit interrupters, or SIs, in addition to GFCIs for enhanced protection against electrical fires. SIs detect arc faults, which are a common cause of electrical fires. 15thly, when running the underground cable, bury it at the proper depth as required by the NEC. This helps protect the cable from physical damage. 16thly, use conduit to protect the cable where it enters and exits the ground to prevent damage from lawn equipment or other sources. 17thly, consider installing a subpanel in the garage to provide additional circuits and capacity for future needs. A subpanel allows you to distribute the electrical load more evenly and provides more flexibility for adding new circuits. 18thly, make sure the neutral and ground bars in the subpanel are properly isolated, unless it is the main service panel. 19thly, if the garage is used for woodworking or other activities that generate dust, consider using dust-tight receptacles and lighting fixtures to prevent dust buildup, which can be a fire hazard. 20thly, install smoke detectors and carbon monoxide detectors in the garage to provide early warning of fire or carbon monoxide hazards. 21st, ensure proper ventilation in the garage to prevent the buildup of fumes from gasoline, paint, or other chemicals. 22nd, use energy-efficient lighting and appliances to reduce energy consumption and save money on your electricity bill. 23rd, consider installing a timer or motion sensor for the garage lights to automatically turn them off when they are not needed. 24th, if you have electric vehicles, consider installing a dedicated charging station in the garage. Electric vehicle charging stations require dedicated circuits and proper wiring. 25th, regularly test the GFCI receptacle to ensure that it is working properly. Press the test button and verify that the receptacle trips. If it doesn't trip, replace the GFCI receptacle immediately. 26th, keep the area around the electrical panel and subpanel clear of obstructions to allow for easy access in case of an emergency. 27th, use a weatherproof enclosure for any electrical connections or devices that are located outdoors or in damp locations. 28th, consider using a smart home system to control the lighting, receptacles, and other electrical devices in the garage. Smart home systems allow you to remotely control and monitor your electrical devices from your smartphone or tablet. 29th, if you are planning to install solar panels on your home, consult with a qualified solar installer to ensure that the electrical system is properly designed and installed. 30th, follow all manufacturers' instructions and safety guidelines when installing and using electrical equipment. In summary, using the existing neutral for your three-way switch as the neutral for the GFCI protected circuit is acceptable and safe, provided that all wiring is done correctly and in accordance with electrical codes. This setup will provide GFCI protection for the receptacle and lights in the garage, ensuring safety and preventing electrical hazards. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns about your electrical work. Remember to always turn off the power at the breaker before working on any electrical circuits, and use appropriate safety equipment such as insulated gloves and eye protection. Also, ensure that all electrical boxes and enclosures are properly grounded and that all connections are tight and secure. By following these guidelines, you can ensure that your electrical system is safe and reliable.